guys, today we're going to do long division with area models. That's what we're working on today, and I'm going to give you a 1-digit number divided with a 4-digit number. Our number is going to be 5,491 divided by 4. That's going to be our number. The first thing I'm going to do that I always do if I'm doing long division or multiplication is do my partial quotients if it's division. So I'm going to make my partial quotients. This is a 4-digit number and every digit is bigger than 0. If this number 5,491 had a 0 anywhere in the number, then you wouldn't have 4 partial quotients. You would have maybe 3 partial quotients, or if there were 2 zeros, you'd only have 2 partial quotients. So it depends on how many numbers that are above 0. And all of our numbers are above 0, so I'm going to start with the first one, and I'm looking for the value of the digit. That's what partial quotients are. So the value of the 5 is 5,000. The value of the 4 is 400. The value of the 9 is 90, and the value of the 1 is 1. Now I'm going to take and make an area model. It has 4 different sections, the way that we're setting it up this way, so that we can use our partial quotients to start with us and help us get the answers. The first partial quotient is the largest one, and it's going to go in the first box. Then I'm going to put 400 in the next box, 90 in the next, and 1 in the last. My divisor, which is the number 4, it's my divisor, I'm going to place it out to the left-hand side. My question when I'm looking at all of this is, I'm trying to use the divisor to make 4 equal parts or 4 equal shares. I want everybody to have the same amount or as close as possible. I'm going to start off by covering up all the zeros on 5,000, and I'm going to think to myself, will 4 fit into 5? And it will. 4 will go into 5 one time. So I'm going to place a 1 up here, and then 4 times 1 is 4. But now I'm way off. That would be 5,000 minus 4, and that's way too far off. So what I can do is I can use my zeros, and I can go add a 0 up top. That puts 1 down below, because 4 times 10 is 40. I'm going to add another 0. 4 times 100 is 400. And add 1 more, and then I have 4 times 1,000 is 4,000. Now I subtract. When I subtract 5,000 minus 4,000, I'm going to end up getting 0 minus 0 is 0, 0 minus 0 is 0, 0 minus 0 is 0, 5 minus 4 is 1. So I have 1,000. And I'm going to carry that over to the next group. When I carry it over, I'm going to do 1,000 plus 400. When I add 1,000 plus 400, it's going to be 1,400. Now I cover up everything but the 1, and I say, will 4 fit into 1? And it won't. So I move over 1 more place value, and I think, will 4 fit into 14? And it will. 4 times 4 is 16, so that's too big. So I'm going to back it up, and I'm going to go 4 times 3 is 12. And now I can do my trick with my zeros. My trick with my zeros is add a 0 up top and 1 down below, because 4 times 30 is 120. 4 times 300 is 1,200. And now I'm going to subtract. 0 minus 0 is 0. 0 minus 0 is 0. 4 minus 2 is 2. 1 minus 1 is 0. I have 200 left over, and I need to carry those to the next block. I carry them over and add them, and this number becomes 290. Now I'm thinking to myself, will 4 fit into 2? It won't. I move over a place value. Will 4 fit into 29? 4 times 5 is 20. 4 times 6 is 24. And if I do 4 times 7, that would be 27. I think that's the closest that I can, I'm sorry, yes. 4 times 7 is 28. I'm sorry about that. 4 times 7 is 28. So 7 is as large as I can go, and that's going to be 28. And I'm gonna do 4 times 7 is 28. 4 times 70 is 280. I subtract. When I subtract, I end up with 10. And I move the 10 over and make this 11. What can I multiply 4 by to get close to 11? 4 times 3 is 12, and that's too big. So I'm gonna think 4 times 2 is 8. What is 8? What is 11 minus 8? 9, 10, 11. It's 3. My answer, which is my quotient, is listed up top. This is my answer up top. I'm going to add this together, and then my remainder is listed down below. So the top is 1,000 plus 300 plus 70 plus 2. So my Q equals 1,372 with a remainder of 3. And that's how you solve a long division problem using area models. Good luck!